In these next few problems, we're going to graph linear inequalities. Now, graphing linear inequalities is very similar to graphing linear equations, except for there's two different things. One, we have to do some shading, and two, we have either a solid or a dashed line. The inequalities will tell us whether it's a solid or a dashed line. If we have strictly less than or strictly greater than, it's dashed. And if we have greater than or equal to, less than or equal to, it's solid. So dashed, solid. Excellent. The other part will be the shading, which we'll deal with in just a second. So let's graph the line. Very similar to graphing a regular line. I'm going to start at 2 for my y-intercept because of this guy right here. My slope is 1 because we don't see any coefficient out in front of the x here, so we know that's just a 1. So I'm going to go up 1 and over 1, up 1 over 1. Oh yeah, we got 4 points there. We really only need 2, but it's fun making points, so why not do a few more? And then I'm going to have a dashed line since it's strictly less than. Y is strictly less than x plus 2. Next we have the shading. Now there's a couple ways of doing this. You could do a test point. For example, I could test 0, 0. If 0, 0 works in my inequality, I'll shade on this side. If it doesn't work in my inequality, I'll shade on this side. So if I plug in the point 0, 0, 0 for x and 0 for y, I'd have 0 here, 0 plus 2, and I'm left with 0 is less than 2. Is that true? Why, yes, it is. So I'm going to shade on this side of the line. Now there's other ways of thinking about it as well, but that's one of the most foolproof ways of going about the problem. I usually look at the line, and if y is less than, I'm going to go below a point. So I pick a point on the line, I say, okay, well, where is y less than? Well, these numbers are smaller than 2, so here's 1. Okay, well, it's going to be on this side. If it said y was greater than, oh, I'm going to go up from that point, and I would shade on this side. So there's a couple ways of going about it. The point one, where we plug in a point, is the most foolproof method, I'd say.